He will, he will talk about the intricate interplay of languages, drawing parallels between ancient Sanskrit grammar, modern linguistics, and the cutting-edge world of artificial intelligence. I will now request the India Center's chair, Professor Pankaj Jain, to introduce our speaker.
Thank you, Sanchari. It's my privilege to invite Professor Girish Jha to deliver 25th lecture, 25th webinar for our India Studies series. I will now read his bio and then he'll take over. Professor Girish Nath Jha is currently the chairman of the Commission for Scientific and Technical Terminology, Ministry of Education, Government of India. He's a professor of computational linguistics at JNU, Jawaharlal Nehru University in Delhi, at the School of Sanskrit and Indic Studies. He's also a concurrent faculty at the School of Engineering, Center of Linguistics, and at the Special Center of E-Learning in JNU. Professor Jha has served as the chairperson of the Special Center of Sanskrit Studies, JNU, and was the founding dean of the School of Sanskrit and Indic Studies at JNU. He has also held the position of the Director of International Collaboration and as coordinator of Ayurveda Biology program at JNU. His research interests include Indian languages, corpora and standards, Sanskrit and Hindi linguistics, lexicography, science and technology in Sanskrit, machine translation, e-learning, web-based technologies, RDBMS techniques, software design and localization. Details of his work can be obtained from his website, sanskrit.jnu.ac.in. Professor Jha has done collaborative research with the Center for Indic Studies, UMass, Dartmouth, USA, as Mukesh and Preeti Chatter Distinguished Professor of History of Science. During 2009 to 12, he was awarded DAAD Fellowship in 2014 and 2016 to teach digital humanities and Indology at University of Würzburg, Germany. And he has also been a visiting professor at the University of Florence, Italy, and to the Yogyakarta State University, Indonesia. He has been awarded the Datta Peeth Asthana Vidwan Award for Sanskrit and the KECSS Award for Reviving Sharda Script. He holds MA, MPhil, PhD from Linguistics in JNU, and I'll now request him to take over. Thank you, Professor Jha. And floor is yours. You need to unmute, sir. Yes.
Thank you, Professor Jain, and thank you, Dr. Chaudhary, for inviting me to this very important lecture. And we have been trying to plan it, and because of the scheduling issues, we could not do it earlier. So now finally we are on. So I'll be speaking on these topics, basically starting with Sanskrit tradition in linguistics and its connection with AI. And then we'll go on to talk about the requirement of AI in India, in a very diverse country that we are, and what we need to do and what we are doing, and kind of an assessment. And finally summarize that, what kind of AI we need to take forward, and what are our advantages and strengths and weaknesses and challenges. All of that will be. So most of you would know that in AI, we basically are dealing with making computers intelligent in understanding natural languages. That is the basic premise. If machines are not able to understand natural language, they are not intelligent. And right from the beginning of, when this whole debate started with the Computing Machinery and Intelligence article by Alan Turing in 1950, he started the ball rolling basically, and then people started discussing. So there was a weak AI, strong AI group. But the bottom line is, unless they are able to understand a natural language, they are not intelligent. And the term was used, artificial intelligence, in 1958 in Dartmouth conference. And the person who used it for the first time, John McCarthy, also expressed the same idea that machines have to be understanding natural languages. Now, the problem with natural language and the problem with artificial language and the ability of machines to parse artificial language but not parse natural language has been at the forefront of what we call intelligent computing. Right from the beginning of the whole idea of intelligent computing, the language has been at the center. So in the 40s, encrypting technologies, decryption, the encryption is also done at the natural languages. We encrypt our messages in natural languages, and your your grammar in your brain has the algorithm to decrypt it, and therefore you are able to understand it. If you don't have the grammar to decrypt the natural language communication, you will not be able to understand. So therefore, the same method was used in artificial languages also in encrypting communication. Even today, encryption is a big thing in cybersecurity, as you know. And then they also talked about neural automata. See, the human brain was always in the picture, neural networks, neural linguistics, all of that. Machine translation actually came earlier than artificial intelligence, right? From the 50s, early 50s, they started doing MT, and then there was a scathing review of the machine translation in America, and things came up very quickly, died very quickly, and they said we should do simpler tasks in AI than the complicated tasks like machine translation. And 58, you know, the AI term was actually coined in Dartmouth conference. And 60s, when the problem seemed very complex, they started talking more about theories and the theoretical informatics, complexity, natural language parsing and speech. These were the highlights of the 60s. And the psycholinguistic interpretations of parsers. And obviously, when people thought that things which are very easy for humans are very difficult for machines, you know, therefore, why not study how humans are able to parse a natural language so easily in their brains, you know? And then so therefore psycholinguistics became very important, and psycholinguistic interpretations of human parsing genetic mechanism, and then trying to bring it over to the computing platform was one of the highlights of the 70s. In 1972, the language called Prolog, programming in logic, was discovered or slightly, you know, used at Stanford. And then it became a very important language of the entire 70s and 80s. And in 50s, 59 perhaps, Lisp, list processing programming language was created at MIT, I think. And now even today, Lisp and Prolog are considered the AI languages. You know, even though we have Python coming up very, very, very quickly, and newer languages are coming up, but still the AI languages are Lisp and Prolog. I remember doing a course in 1997 at the University of Illinois Urbana-Champaign when I was doing my second master's at UIUC. So the course was Introduction to Artificial Intelligence, but it was actually a course on programming in Lisp and Prolog. If you did a course today in AI, it would be actually Python and machine learning. Now, so 80s and 90s, logic, inference, unification, all of that, slightly more sophisticated stuff, you know, and I'll be talking about that. And then the last 2 or 3 decades have been a revolution, you know, in the web data coming up in large quantities, so we call big data. And then the resources are becoming available, computing capacities and cost are improving a great deal, and algorithms are going through a sea change. And in a complex society like India or Europe, where we have a lot of multiple linguistic situations, or Africa for that matter, things will be much more complex. And therefore, I see, you know, David Gibbon, whose slide this one says it is very complex. The future is going to be very, very difficult to imagine. AI and its area of study, basically, we do language as the foundational discipline under AI, because unless machines understand language, nothing will progress from there. So computational linguistics or natural language processing or language engineering or language technology, all of that, you know, because is considered the foundational area. And then we have inference engines where machines make inferences, and expert systems. So we make an expert in a particular domain of knowledge. We have intelligent tutoring systems where machines can be used for education. Vision machines, you know, are for a lot of applications. Optical character recognition, you know, reading manuscript, reading handwriting, online handwriting recognition, you know, reading pictures, reading images, all of that. Vision machines, robotics, basically doing mechanical activity, precision tasks and difficult tasks, all of that. And as you know, today AI is synonymous with machine learning, and but the problem remains: AI can only happen if machine understands natural language. And there has been a progress, remarkable progress in machines' capacity to understand natural language. If you see the progress made in machine translation today, and the speech recognition and reading capacities of machine, these are, I call, speech-to-speech machine translation, which we need badly in India. So there have been phenomenal progresses made on these lines by the giants like Google and Microsoft, and of course also in India, We have Bhashini and Vadini initiatives where, and also another initiative under the Principal Scientific Advisor's Office, where the machine translation has been progressing phenomenally in our country. Now, when we say computer has to understand natural language, the computers have to interact with humans using natural language to be intelligent. We need to handle these things. So conventionally, we interact with machines using the conventional means of communication like keyboard, mice, etc. But intelligent communication would be using intelligent means like speech and language. And therefore, the CL and LP, or what we call computational linguistics, so language aspect of AI, strives hard to make this happen, which is the basic premise in AI. So therefore, AI in linguistics it becomes more important because linguistics deals with the structures of natural language, and machines have to understand the structures and layers of natural language to understand the text, understand and respond to a text. So we have layers of sounds combinations, combinatory principles of sounds, and morphology, and the morphological processes, how words combine to make collocations, how units in words combine to make words, how words combine to make collocational usages, and syntax, how words are distributed in sentence in some kind of a template, which we call syntax, which is language specific or language group specific. And for example, in India, we have verb final languages, and Europe, we have mostly non-verb final languages. This would be, we call a syntactic template. And in this template, there is a distribution pattern of words and part of speech categories to make what we call normal human understandable sentences. Semantics, if the words which are placed in a syntactic template in a sentence are making enough sense for the communication to happen, or if the words they do make sense, but the actual meaning that the sentence actually comes up with is outside, the sentence. So all of that is very important in natural language structures, and therefore linguistics is foundational discipline. Now, how it is connected with Sanskrit? Because Sanskrit has the first grammarian of the world, which actually a model language mathematically, and that model is still the most complete model available in any human language. And this was Panini, 7th century BCE. Much before Panini, actually, Sanskrit had a huge tradition of language studies. And these 4 out of 6 Vedangas, we have to have knowledge in 6 Vedangas to be able to understand Vedas. And 4 out of 6 Vedangas are actually linguistic sciences. Grammar is one Vedanga, Shiksha, phonetics is another Vedanga, etymology, Nirukta is another Vedanga, and Chanda, metrics, another Vedanga. 4 out of 6. Other 2 Vedangas which are non-linguistic, kind of, Jyotisha and Kalpa. These are the non-linguistic Vedangas. The other 4 are actually the linguistic Vedangas. So there was a lopsided, actually, emphasis on linguistic sciences because we were constructing texts orally. To construct text orally and error-free, we need to be experts in linguistic sciences. To construct text mnemonically, error-free, so that interpreting it would also be error-free, right? Interpretation would also be error-free. If you go much, little later, Sanskrit's the interpretation sciences in Sanskrit evolved to make sure that the interpretation of the mnemonic expressions, which is sutras, when they do vrittis in sutras, and from vrittis, vyakhyas, bhashyas, from bhashyas, mahabhashyas, right? So this is a tradition. Sutra, you do vritti, and vritti we use linguistic techniques to make sure the mnemonics are expanded enough, and then we do vyakhyas, a little bit more expansion with the ancillary knowledge, and then we bhashya, commentaries, and then we mahabhashya, great commentaries. So this was the tradition in India, and all of the tradition used a unique method of interpretation, which is interpretation without error. And in some of the, like Navvinyaya, if you combine Navvinyaya with Vyakarana, they would like to represent things error-free. So, for example, a natural language sentence would be represented mnemonically, symbolically, so that only one meaning is apparent, from the sentence. And so Rick Brooks' idea was that if India has been doing this, what we basically need in AI is to represent natural language represent natural language unambiguously. So unambiguous representation of natural language is what machine needs. And in India, Sanskrit tradition, people have been doing this. So why not look at that first? And then, so that we don't have to reinvent the wheel in many of the aspects. That's what that was one of the, what Rick Briggs wanted us to believe. So, and then another one, which I always want our people actually to go through, Sanskrit studies as a foundation for computational linguistics. The reason I returned to India to join Sanskrit department in JNU because they had opened this computational linguistics discipline and wanted me to join. And I was in Illinois. I was a software engineer after my graduation from Illinois. And then, so this was the idea. Basically, Sanskrit is the foundation of computational linguistics. There's a lot that can happen with the collaboration with the Sanskritists and the grammarians and the Naiyayikas. And the three people who actually shaped the modern studies, which actually kind of went from language studies to core, and formal studies on language to actually AI, would be these three: Panini, 7th century BCE, and then Ferdinand de Saussure, 19th century in Geneva, and Chomsky, Noam Chomsky in America. So India, Europe, and America, three continents. I would like to credit them the entire developments in this area. So why is Panini important? Let's look at Panini a little more closely. And if you look at his grammar from the top, you find 4 modules. And this is what the grammarians of Sanskrit don't find, because they go through they go into the grammar and they start looking at this the sutras as per the order of Panini, which is the Kashika tradition, or as per the order set by the Siddhanta Kaumudi, so, and then they do not perhaps look at that this the modules that are emerging from the grammar could be also the modules which is the language faculty of human brain, and so Westerners, when the Panini grammar was translated and taught, in fact, Panini grammar is still taught in many linguistic departments. I was visiting professor in University of Florence, and there they teach Panini grammar, at the linguistics department at the University of Florence. So, so if you look at the Panini grammar from top, you find the sound component, which is basically the first reading is what we read is sounds. You speak in sounds, and I read the sounds first. So I should have the sound reading capacity in my brain, which Panini calls the Akshar Samavana phonetic component. And there, Panini has the mnemonically arranged 14 Shiva Sutras, and these Shiva Sutras yield dynamically lists, what we call sound classes, phonological classes. These classes are the basis of any phonological studies, and you can't imagine how much the phonetic studies, phonological studies of the modern disciplines of linguistics have been influenced by Panini. And then the pratyaharas are dynamic sound classes, which are dynamically obtained by running a formula. Adirantin Sahita is a function which runs on the 14 sound classes and generates sound classes dynamically and puts them in some meta terms. I would say the variables, which are lists. These lists are created, used, and lost. So dynamic. This is one of the most sophisticated aspects of programming today. That program actually is dynamic. Rule base of 4,000 grammar rules, and then the lexica. We have verb databases which are critical in any language processing. Without verb roots, you can't imagine to process language. And nominal databases, those nouns which are which cannot be parsed any further. Rudhis, which are these, I would call them stems, basic stems, there. And then the lists, smaller lists which are part of the sutra part or the main grammar. So any sophisticated program today has the databases outside, external. So these two databases are actually external to Panini's grammar. Panini's grammar is this, and also this, perhaps, these two, and this also. This one is external, right? So any database, a good database, would be outside the front end, and the front end makes a call to the back end to access the database. So Panini's system is more formal, and I would call it largely unambiguous procedures. I don't think Panini is entirely unambiguous. He himself says that if there is ambiguity, what to do? Vipradishadhe param karyam. If two rules apply, at the same time on a string, there will be two outputs. In that case, in that case what to do. And he says the one which comes later has more force, which is more forceful actually. The Panini's structure is similar to a program, very similar to a program, I would say. And a lot of the ideas from Panini's grammars, techniques have been used in programming. And variable instantiation, we create variables and we assign values, and then we use them, and then we destroy the variables. And then since we are creating meta terms in Panini and variables, so to understand, we have to do vriddhi, expansion and evaluation, constant evaluation, expansion of the terms have to be done. Similarly, a compiler, or before you write a code, and before it gets compiled, the compiler has to expand all the meta terms with the necessary constituents, and then be able to examine the code. And if code is all right, then actually it translates that into bytecode. So the phrase structure rules and replacement procedure, which were actually the hallmark for compiler design, was certainly influenced by Panini. So some famous quotes, let's see, Bloomfield, what many people call the father of American structuralism, was a linguist. And he says, the descriptive grammar of Sanskrit, which Panini brought to its perfection, is one of the greatest monuments of human intelligence. Right? And then also, this is in the introduction of his book called Language, which was published in 1929. Even Motilal Banarsidass has done a paperback edition of the book, very famous book. You should read the introduction part at least. And it says the indispensable model for description of languages. So what he says, if you're describing any language of the world, what you talk of Indian languages, you need Panini. You cannot avoid Panini, if you're describing natural language. Now, if you extend that to artificial language, so Panini was used perhaps more for describing artificial languages, and through Chomsky, I would say. And Ashtadhyayi encyclopedia says has been compared to a Turing machine, which was designed by Alan Turing in 1950. It's a machine which evaluates any complex structures to its ultimate constituents. So the complex structure to intermediate to more intermediate if possible, and finally to ultimate constituents. There's no further parsing required. And he says even Panini's grammar are exactly the same thing. If you have a constituent like Bhavati or Rama, Ramen, etc., then the machine will, Panini's automata will start evaluating it and go to the ultimate entities, and it will stop if there is no further processing possible. And what these guys say, that human brain and an intelligent machine has to be like that. A human brain also, whenever you hear a complex input through speech or through visual stimulus or anything, your brain starts processing it, and it will not stop until it has reached the aim, right? And Monet William has to say that the concept of metastructure a meta language was first given by Panini, and he constructed it about thousands of years before computer scientists began exploring the same idea. And he says no one has been able to match him to this day. This is 1930s, I would believe, right? 40s, when Monet William would have perhaps made this comment. Why Panini is important in computing? Because Panini formalized almost everything, and including the most difficult, which is natural language. Natural language is creative, and to compute natural language has still been a challenge in many, many areas. So some examples of what I call a sophisticated programming in programming techniques from Panini. Let's say generating dynamic lists on the fly, Shiva Sutra, and Pratyaharas and Adirantin Sahita. So if you have the Shiva Sutra, 14 Shiva Sutra, they generate Pratyaharas by running a program called Adirantin Sahita. And we have what is called the Adhikara Sutras, which are like an importing an API, application programming interfaces. So for example, the Panini database, the Dhatu part, is external. And when Panini has to pull some verb root from some class, he makes a call to the external database by calling Dhatoh. And Dhatoh, the database becomes internal, exactly the same way as we do programming today. And then he starts picking up the targeted entity from the semantically classified roots in the database, and then starts processing. The placement of that entity in the semantic class determines what kind of processing will happen on that entity. Right, so very nicely arranged, what I call the most sophisticated relational database stuff over there. Anuvritti, iterations and recursions, these are the techniques that are used in programming. And paribhasha are the meta rules and conflict resolution. If there's a conflict, the two more than one output, ambiguity, then how you resolve it is also given over there. Dhatu part database, I already mentioned. Sanya sutras, variable instantiation, assignment of values. At least dynamically extending the scope. If during the course of processing, the grammar, the program feels that there's a need to extend the scope of processing. It can dynamically extend it. And by contrast, it can dynamically also restrict it. Niyaman and atideshan, these two. And vidhi is the trigger operations basically. If then else rules. If two simple vowels meet, the result would be elongated vowel. If palatalized vowels, if the like e, u, etc. Vowels are followed by palatal sounds, similar, and some other vowels, and then it becomes it ends in palatal sounds. So prati, eka, pratyeka, ya will be augmented over there. Similarly, dynamic restriction and nishedha. Nishedha is you apply rules, but look at the constraints. The rules apply under rules do not have unrestricted application. Their applications are restricted by constraints, and constraints have to be satisfied before an optimum output comes out. And this technique was used by optimality theory in linguistics, or syntax and phonology, of course, by Prince and Smolensky. I think 1997, 1998, the famous book Optimality Theory came, and he has a big section of Panini phonology over there. Ferdinand de Saussure was a Swiss linguist in the 19th century and early 20th century, and he had a PhD in Sanskrit, generative absolute, Sanskrit Karaka, and he lectured in Geneva for 3 decades, and he may have been influenced by Panini and Bhartrihari. Obviously, I'm being more generous in saying that may have been influenced by Panini and Bhartrihari. His idea of signified and signified would have some resembles, what these guys, Bhartrihari, Patanjali, etc. do. And more importantly, the very idea that formal rules can be applied to areas outside logic and mathematics may itself have been catalyzed by Europe's interaction with the work of Sanskrit grammarians through translation. Noam Chomsky, another one, currently he's with the University of Arizona, and he was at MIT most of his career, known for universal grammar, transformational grammar, cognitive linguistics, initiativism, and successfully destroying Skinner's behaviorist ideas on language acquisition and all that. And he gave Chomsky a hierarchy of 4 grammars, formal grammars, which could be used for describing artificial language or natural languages. And these grammars were, basically unrestricted phrase structure grammar type 0, type 1 context sensitive grammar, type 2 context free grammar, type 3 regular grammar. And out of these, the type 2 grammar, context free grammar, was used for compiler design. Chomsky was a linguist, and he studied in computer science. Now, apparently, if you compare with Chomsky's grammar, you see stark similarities. So Chomsky's 2 very important books, 1957, Syntactic Structures. And I think in that book's introduction, he talks about Panini being also the generative grammarian. And aspects of the theory of syntax, 1965. From these 2 grammars, the model of grammar that emerges. And when we say grammar, we don't mean grammar of all language. Grammar, which is basically universal, which is specific to human brain, something like that. It can be extensible to cognitive level. So base component and the deep structure, and then the transformational component, 3, and the phonological component, 4 components. He also has 4 components: base component, deep structure component, transformational component, and the phonological component. So he says the base component has phrase structure, rules, and lexicon. In Panini, these are the sutra and the dhatu-pad gan-pad lexicon, 2 lexica. Panini has 2 lexica, dhatu-pad gan-pad, and the sutra part. So Panini, this is sutra part, this is dhatu-pad gan-pad, which gives you the analysis of the input. And then you apply semantic component, which is karaka in Panini, karaka structures. Then you apply transformational, which is vidhi in Panini, derivation process in Panini. So derivation in Panini. And this is phonological component, which is the speech component, which is Panini's Akshar Samavanai. But in Panini, this is the first component, and here basically in terms of utterance and output. If you compare the Panini's grammar with context-free grammar, which is Chomsky hierarchy type 2 grammar, which were used for compilers, you see similarities. So in context-free grammar, the grammar G, formal grammar G, is a collection of non-terminal items, which is the part of speech categories. Terminal items, which are the actual words or the strings from the language, and the production, which is basically the direction of derivation. The left hand side being replaced by right hand side, and the start symbol, where to start, what to start with. And if you look at in Chomsky's system, we have noun phrase, verb phrase, determiner, noun, verb, etc. The morphological, the part of speech categories which are implicit in the human brain. No matter which language you speak, you have your part of speech categories. You may call it noun phrase or sanya, whatever, but there are part of the categories implicit in your classification mechanism of human brain. Because when you heard words or sounds, you start classifying them, putting them in some category. And at the syntactic distribution level, we have these what we call part of speech categories, which basically describe the distribution of words in a syntactic template. In Panini, we have a little bit more abstraction, and Panini's grammar is much more abstracted, and more abstraction means more cross-lingual application. So we have Savarna, etc., etc. A lot more categories created by Panini besides the regular part of speech categories, which are basically implicit, already there, understood. There are much more complex categories evolved in Panini. The terminals are actually the words from any language, but in Panini, besides the words, we have the sounds also. Because we are constructing text, we are constructing things orally only. There's nothing called written in Panini's system. So we have basically, the sounds as well as the verb roots. Verb roots are the basis of starting the process. The production is A equal to alpha, left hand side replaced by right hand side. Obviously, even in Chomsky, things are not always unconstrained. There are four sets of formal grammars: unrestricted, constant, free, constant, sensitive, etc., etc. But Panini things are always in the form of A goes to B if C. For example, akaha savarane dirgha, that's Panini's formula, says aka, which is again evaluated as a, e, u, ril, ri, if followed by savarna. Savarna is the sounds from the same phonological classes, or similar, comparable phonological classes. Savarna is tulyasya prayatnam savarnam. Tulya asya prayatna. Those which have comparable, tul is comparable. Comparable asya, place of articulation, and manner is, prayatna. If two sounds have comparable place and manner of articulation, they are called savarna. If a sound class called akka is followed by its savarna category, the result will be dirgha. For example, griha plus agata, grihagataha. Vidya alaya, vidyalaya. For example. So basically these are the categories. A goes to B if C. All the Vidhi Sutras are basically in this format in Panini. And the start symbol again is much more abstract in Panini. Start symbol in Chomsky is S, which is utterance. It comes out of mouth. And the start symbol in Panini would be the one which is not uttered. So S bar, the vivaksha, the desire to speak. But a lot more goes before the sound is uttered out of the mouth. So if you compare Panini with another level of comparison, so I'm comparing Panini, Chomsky at three levels basically. Panini with the Chomsky's grammar models, Panini with the formal grammar, which is context-free grammar, which were used in compiler design. Now Panini with the Backus-Naur form, which were used for CFD for compiler description, right? Compiler basically is a description. We describe programming languages, right? So that programming languages communications are translated in the binary. Now look at the context-free grammar expressed in the Backus-Naur form, Backus-Naur convention. So S will be sentence is replaced by noun phrase and verb phrase in any language, right? Because we have a sentence is always, obviously one of them could be optional, right? Even noun phrase, something has to be either noun phrase or verb phrase. Both of them are not compulsory. But in programming language, they're compulsory. Human languages, you can omit things and still be understood. In programming languages, they are compulsory. Otherwise, the compiler will not compile, right? That's the constraint that we in programming languages. And Panini says, Pad is Subanta, Supanting. Subantan Tinganta. Subanta is a noun phrase and Tinganta is word phrase. Obviously, he didn't have noun phrase and word phrase, the English terminology then, obviously. No. So noun Subanta Tinganta. What is sup? Any string ending in sup suffixes. What are sup suffixes? Again, that's a mnemonic. Su, or, just, out, such, ta, bhyam, bis, all the way up to, all the way up to Saptami, right? And similarly, what is thing? The 18 suffixes, tip, tas, ji, etc., all the way vahing, mahing, so everything is so mnemonically compressed in Panini that you have to do constant evaluation, expansion. And then, similarly, word phrase in Chomsky would be V goes to NP, because European languages, it is not final. So this one means basically it is done for a non-Indian language, the language which are not verb final. In India, verb will be final. It will be NPV in Indian languages. No, we don't, we apple eat. We don't eat apple. We apple eat, right? In India. So, but in Sanskrit, let's see. Sanskrit says, it gives more more room for abstraction. It says the KP or Kriyapad will end in Kriya, and there could be structures left and right depending on which way the language goes, right? There's much more, much more abstraction. It leaves room for more cross-lingual application. Therefore, when Bloomfield says Panini's grammar is indispensable for description of languages, that's what he meant. So here you see the problem is if you say VNP, it only applies to European languages which their verb is not final. But when we say KP goes to K, left or right, there could be structure. It means it applies to all languages, whether the verb final or not verb final, right? In India, it will be K here. K will be end. In Europe, K will not end, right? And therefore, noun goes to cat, dog, etc., and here would be Rama, Shyama, all the 21 avatars or inflected categories. Similar verbs will be all the inflected forms. But in Sanskrit, inflected forms plus the stems will also be, roots will also be there, and determinants will be absent in Indian languages. Now, CFG in BNF has simplified the definition of programming language and compiler design. This has been the basis for creating compiler. Even today, this is the basis. From Panini to Saussure, from Saussure to Chomsky, from Chomsky to computational linguistics, and from there to artificial intelligence. This could be the direction of movement because the computational linguistics came before AI. Before AI was coined, machine translation had started happening, and the talk of making intelligent computers which understand natural language were already starting with the 50. So this certainly computational linguistics must be, predates artificial intelligence. Now the idea obviously came from Panini. What describing natural languages or programming languages exactly using rewrite rules, number one, and from Panini to Saussure, from Saussure to Bloomfield. I'm kind of expanding the list. From Bloomfield to Jelly Harris, which was one who inspired Chomsky to do linguistics, and John Backus. They were almost contemporary. John Backus, Backus Normal, Peter Knorr, Backus Knorr for BNF. There was one guy who, Peter Zilahi Ingerman, 1967, he wrote an article, letter to ACM, asking them to give Panini the credit. He said we should have Panini Backus form and not Backus Knorr form, So, and he wrote a letter, if you can see this letter very nicely, and he has done his research in why Panini should get the credit for this, and he said, please give credit to Panini. And I'm told they actually gave credit to Panini, and it was called Panini Backus form for a significant period of time. But later on, it kind of went back to the Backus Knorr form. So Panini's technique and abstract notation system used in accurately describing natural language structure is very similar to John Backus, IBM designer in 1950s, who described a new programming language called IAL, International Algebraic Language, or ALGOL. So ALGOL was created getting inspiration from this technique of Panini, rewriting things from the left-hand side unambiguously as the right-hand side, and doing it continuously till you hit the dead end. There's no further description needed, right? With all the constants, of course. So now, with this background of artificial intelligence connection with India, let us see what exactly we need to do in AI and how we can benefit from it in India. So we need to have what is called input-output mechanisms. When I say IO mechanisms, I mean smart IO mechanisms, not the what is called the regular conventional IO mechanisms. I mean, I should give commands to machine in speech. Go to the next slide. Go to this slide, that slide. Search this, and prepare a summary. Prepare a PPT for me. All of that is going to come very soon, right? Prepare a project document, do an evaluation of the project document. This is the answer sheet, grade the answer sheet. All of that will be part of what we call input-output mechanism, getting tasks done by machine. Now, taggers are basically where we do classification. Pierce taggers is a misnomer. We should just call it taggers. The taggers are of all kinds. We do part of speech tagging. We do sound classes tagging. We do semantic tagging. We do named entity tagging. Any tagging basically. Tagging any product. Tagging any procedure, operation. In any discipline, in any field. Tagging financial data. Tagging images. So tagging the expressions on the face with some tags. So we need tags or classification system to make sure the data is unambiguously portrayed and classified so that machines have it easier in learning. Similarly, morphological analyzer, we use morphological tags basically to classify words and their actually structural usage within short chunk. And parsing is full blown for the entire sentence. Automatic speech recognition is where speech is recognized in writing, so to say, by machine. We speak and machine writes. And speech synthesis is the reverse. We write and machine speaks. Machine translation, all of you know, automatic translation, across lingual information access, where the information is asked in another language, and while the information is not available in that language. So, for example, I need information. I'm a Khasi speaker. I give a command. I ask Google in Khasi, and there is no document in Khasi to search. So what Google will do, it will translate that Khasi query in English or Hindi or Bangla, whatever is availability, and then search documents in those languages, and then basically translate it back into Khasi for the benefit of the user. A user doesn't know where the information comes from. It's called cross-lingual information access. Automatic localization, which I'm currently doing, for one of my websites. And I remember doing a very interesting project when I was a software developer in Java in America, where I automatically localized an English programming language code into Spanish using automatic translation. So program will wake up in the middle of the night in American time and scrape all the strings from the code, actually, the double quoted strings, and send them to altavista.com, get Spanish outputs, and put them back instead of English strings, and compile the code and put it in the respective folder. And so the entire website now becomes a Spanish website. So all of that, I'm currently using a little bit more mundane technique to translate our website. I just wrote a website called shabd.education.gov.in for my CSTD terminologies, which are now live. We went live first week of March, and now we have more than 8,000 users already. And so I'm currently making it multilingual. Anybody can access in any language. So I'm doing it same technique here. Anyway, so automatic localization is when you are able to access any content, any website, any software in your language, and machine does automatically convert entire content to your language, menu, etc. Text summarizers, where we do summaries of text for the paucity of time. For example, a big judicial document has to be read very quickly by judges, so machines can do summaries. One of my PhD students did recently Sanskrit text summarization. Dr. Shagun Sinha, she wrote an abstractive summary algorithm for Sanskrit text. Named entity recognition. One of my students did a PhD on Panchatantra, automatically recognizing names from Panchatantra. For example, the weird names in Panchatantra. For example, Karkat, Damanak, Mahila Ropya Nagare. These are, so can machine automatically tag these as names? And so the machine translation process bypasses it, doesn't actually start translating these terms. Similarity in methods. Now what happens, the methods in these disparate areas linguistics, Sanskrit, and AI are very, very similar. So in linguistics, we use what is called quantitative methods, experimental methods, observational methods, and fieldwork, of course, and corpora-based studies. And all of that is used in AI also, For example, quantitative, we do data analysis, data visualization, which is the hallmark of data science today. And we do a lot of stat and probability. And of course, we use ML algorithms. ML algorithms are used in everywhere, every discipline, actually, for analysis and visualization. Experimental methods are used in some areas of linguistics, where, for example, psycholinguistics, neurolinguistics, and of course, in computational linguistics, wherever you need that kind of targeted experiments. Observational methods, for example, we have to observe the behavior of some speech community. For example, currently I'm doing a niche pilot project for Google to observe the linguistic usage of Bhojpuri community, the Maithili community, and the Haryanvi community, how nuanced Hindi usages are done by these people, and how those could be translated to standard Hindi so that machines can then take over from there. And then using survey techniques and all of that. I've done some work for some universities. For example, we did a project. I was hired as a consultant by Mahatma Gandhi Hindi University, and we did geography, dialect mapping for many languages of the Hindi area. For example, the Hindi has 55 varieties, so we did a lot of work in that. So, and we had our own method in doing that. Fieldwork, of course, when we have to document some language, we have to get data from the people, and we have to go to the community to get data. And once we get data, we put them in some standard, annotation or on transcription scheme, and then we start looking at the patterns which emerge from the data. It's the most interesting aspect. Once you have documented the data, you start doing the analysis and visualizations. What patterns emerge from the data, and that lead to a lot of findings. For example, the case of Bangani data, which is a dialect of Garhwali. Garhwali is a dialect supposed to be a dialect of Hindi. So Bangani fieldwork was done by Professor Klaus Peter Zeller, and he found a lot of Cantum properties in the Bangani data, which is now becoming very, very prominent in the so-called Indo-European in the debate. Now, the methods used in NLP and AI are all relevant methods from from linguistics, computer science, stat, probability. And in addition, we use methods from programming in databases. Of course, we have to do a lot of data science. And I encourage all the linguists and language people to actually learn database techniques, which is very, very important. You can do perhaps much more with database techniques than non-AI programmers can perhaps do with it. And also, corpora-based techniques are very, very important. I wish I will have some time to talk about corpora also. Professor Jain, how much time do I have? Till 12:30,
how much time would you need?
I thought I have one hour and 30 minutes, right? So I was aiming at 12:30 till 12:30. Is that all right? Or
usually we finish within an hour. Yeah.
Okay, so then.
But it's fine if you want to take some more time.
Okay,
it's fine.
So give me 15 minutes then.
Yeah, fine.
Okay, thank you. So then I'll skip some of the slides. So today, basically, we have moved from the classical AI, what we call the, where we gave grammar and lexicon a priori. Now we basically ask them to process grammar and lexicon from data. So if you look at the previous models of grammar, which were used actually, what's the keyboard here? Okay, so I have a previous thing. I'm currently working on a keyboard. Okay, so this is the grammar which I did for University of Illinois Urbana-Champaign. I passed English language for SQL conversion. My master's thesis over there. And there basically used Paninian technique. It was basically attribute value grammar and Early's algorithm and Prolog as the language. But if you look at the structure, it's very similar to Panini. To first create meta terms, which Panini also creates a Vriddhi, Gun, etc. Then use these terms in writing the grammar. Panini does the same thing in Sutrapat. Then use the same terms to use the lexicon, create lexicon. Exactly the same way as Panini does. And then today we have ML methods, and then the formal grammar methods I would use perhaps with Panini. And I am very fond of this method, human head-driven phrase structure grammar. This is very similar to Panini's Karaka. These are, and so you would perhaps read about them if you are in this field. Now, the machine learning methods today are very popular, and I'll not go into the details of what exactly these are and how we do it. We'll skip that. And there are some integrated platforms which you can, if you're interested, you can go to. If you are Java enthusiast, go to Java platform, Python platform, etc., whatever you need. And this is our platform here at JNU. We have a Sanskrit server, and I have basically created a huge parallel corpora platform on my Sanskrit server. We have 5 machines: Panini, Patanjali, Katyan, Bhartrihari, Nagesh, all grammarians in my center near my office in JNU, and these have all the computing power. And here, basically, you can create a workspace for any language in India. People can join and create resources for machine learning. This was the project funded by IT Ministry. They gave me 17 universities in 2009, and it continued all the way up to, I think, 12 or 13, I believe. It was a huge project. I'm not going to that. So this is our platform. It can also be used. Of course, we need some training for that. The language situation in India, of course, is very complex, and we have 20 official languages plus 38. 38 have been applied for. So there are 38 applications pending at the Home Ministry for an inclusion in the 8th schedule. And I don't know how many will be there, because it's very complex to include a new language. A lot of resources have to be utilized. For a lot of complexity is triggered. 1369 plus minor languages and varieties, and multilingual TV, media, language policy, education policy, governance, health. Everything is so complex in India, and therefore challenge is that we have to have very smart technology built on what is commonness across Indian languages. That is the critical thing here. So if we look at the applications of AI in India, we'll have to have collect a lot of data from different domains. Wherever we want AI to happen, we want AI to happen in judicial documents, judicial area. We have to have judicial documents, a lot of data, a lot of complexity over there. We have Supreme Court in English, high courts in English and regional languages, major regional languages, and district courts. We have, I think, 21 or 25 high courts perhaps, and we have 672 district courts, which are used in regional languages. And most pending cases are actually in the district courts because of the linguistic multiplicity over there. Newspapers, print media, literature, film, television, all of that needs AI application in big way, and we need to have data from these areas and generate language informatics, which will then be the bedrock of AI in India. What is critically needed? We need these tools, of course, as I said, real-time machine translation, and then text integration, dialogue recognition, multimodal technology, indigenous algorithms critical. We need to build our own algorithm. We need to build our own data centers and our own cost-effective, multilingual, flexible AI. Very important. What is happening in India today? 3 levels. Anuvadani is the machine translation by MOE, Ministry of Education, and Ministry of Information Technology is funding Bhashini, and Principal Scientific Advisor of Prime Minister Modi has an initiative called IC Maths Innovation Challenge for machine translation. I happen to be in all of them. Here we have an agreement to give all our vocabulary to them to retrain the machine translation to be adaptable in a specific scientific and technical domain. This one is India's own, A to Z technology, and this one is we are seeding startup companies to use machine translation or to create machine translation for language pair. Indian academia, these are the institutes primarily involved, but primary institutes become secondary, secondary become primary, major become minor. So there's a lot of upheaval happening. Newer institutes are actually getting added, and older ones are fading away. All of that happening. Industry currently, Microsoft, Google, these are the major players. SwiftKey, I consulted for SwiftKey. It has been bought by Microsoft, and Amazon AI, Samsung, Adobe, Nuance, EasyDI, I'm advisor. A lot of startup companies, etc. And we have our own startup company here. Google is a major player. You know about Google, so I'll not go into what Google does. Microsoft, another major player, and Amazon coming up within a big force. There has been a lot of upheaval actually in the field because of the ChatGPT stuff. Apple and Samsung and startup companies and SMEs, etc. in some nuanced areas. At JNU, we have done a lot of work, and I'll do a very quick summary of what we do at JNU. So we've done projects funded by the government of India. Currently, in the Bhashini, doing Hindi to Maithili machine translation. It's just started. And I've done this huge Indian language corpora initiative. I showed you the platform. There we built corpora for 17 Indian languages, including English. parallel annotated corpora for 100,000 sentences from 18 domains. And there's a huge corpora, perhaps the best corpora India has ever produced. And then we did machine translation for consortia, again shallow parsing for consortia. Consultancies currently, I'm Google's doing a pilot project. I have joined ministry, so I'm taking more time to finish it. As I said, I'm doing trying to understand nuanced usage of Hindi in these three dialects, and how to make sure the Google Assistant machine translation are able to capture it. And we did a similar initiative, a little bit more linguistic the previous year. Nuance is 16 for Kashmiri keyboard, Swift key for 5 languages predictive keyboard, including Sanskrit. And if you are able to use a Swift key keyboard from Google Play Store, you will be using our keyboards if you have used these languages. And Swift key was purchased, taken over by Microsoft in 2016. I was consultant on Microsoft 2006 for handwriting recognition. I was LDC consultant, University of Pennsylvania, 2011 for 8 language multimodal data recognition. It was a US defense project given to University of Pennsylvania. And I had also given a talk over there. I was again a consultant for Microsoft 2013 for developing their English to Urdu machine translation. If you check this site, you'll see in collaboration with JNU. So we have a stake in their English to Urdu. Now it has actually improved. 2013 we launched it, and now it has become much more smart English to Urdu. It's basically Hindi in different script, but with some stylistic variation, of course. We have our monster tools for those languages which do not have the resources. This tool can quickly generate resources and create frequency dictionary, all that, and it also takes into account the copyright issues also. So our students have been doing a lot of research. 46 PhDs have been completed, and currently we are focused on text summarization, Sanskrit programming language interfacing, automatic speech recognition, MT. And I'll quickly show you some of the PhD topics. You can go to our server sanskrit.jnu and look at some of the PhD topics. Some of them have posters also, and what exactly has been done so far. And if you can give us some feedback. Currently we are focusing on automatic speech recognition with the help of European Language Resource Association, ELRA, and machine translation in different language pairs, like Sanskrit Nepali, Sanskrit Hindi. And we showcase our achievements every 2 years in international fora. So this May, we are having a seminar in Italy. We have our committee, program committee for evaluating papers, etc. And then this seminar is usually funded by Microsoft. And we're hoping that they will fund this year also. We'll be able to take some students. This is our website, sanskrit.jnu.ac.in. This is our YouTube channel. So finally, our progress depends on AI, and the connection of AI with Sanskrit and linguistics is our strength, and a huge manpower which could be potentially trained into some interesting data creation aspects of it, on the lines of Samar Institute of Linguistics in America, planning something similar for the Indian students of Sanskrit in JNU. Even today we have kind of a brainstorming session at 2 o'clock. So we have to basically focus on our strengths and apply AI in these critical areas, which we need badly: governance, education, health, disaster management, languages, cultures, knowledge, traditions, etc., etc. These are critical areas. In the multilingual education happens to be the most critical, because we have to deliver education in 270 mother tongues, and that's a huge call. Cannot happen without technology. We need our own AI using Sanskrit for common core, because in all these 1369 languages or even more, we can't do separate tools development, etc. We can perhaps look at what is called common core method, which I call Sanskrit as the basis for the common core: Sanskrit vocabulary, Sanskrit grammar, methods, morphological processings, and the idea of grammar from the Sanskrit language, and all that could be the common core. And then we can have the nuances of each language as the plugins. For that, we have to create resources for Indian languages, and then and also apply this to educational technology. Of course, we have to have our own data centers, all of that. But we have our own challenges. Our challenges are diversity, language variation, mixing, positive standards, funding, casual approach towards our languages, teamwork, lack of competition, complexity of natural languages, more so in multilingual societies like India. All of these challenges are there in India, perhaps more severe in terms of funding, but we have to actually handle that. And then there are challenges from AI too. As I said, AI has evolved faster, and it will evolve much more faster from now on. And I gave you example of the course which I did at UIUC in 1997, Introduction to AI, which was basically course in programming in Prolog and Lisp. And now if you did a course, you'll do Python, machine learning, and deep machine learning. When I send my students for exchange to Zurich University, they go and they come back and tell me they did a lot of semantics in machine learning. So a lot of semantics is going to come back. And remember doing a course, mathematical linguistics in the UIUC during my master's, there's a lot of mathematical semantics actually there in that course. So these things will be, coming back with a lot of bang, and we'll again be focusing more on Panini when these things come. Yeah. So thank you so much for giving me this opportunity to speak to august audience, and it's a very eminent university, and I enjoyed being with you, and I hope there'll be a good interaction afterwards. Thank you so much, Professor Jain.
Thank you, Professor Shah. It was really enlightening, extremely technical, very interesting and innovative. One of the most innovative presentations ever, I think. Thank you so much. And let's see if there are any questions by participants. They can ask, they can unmute themselves and they can ask their own questions if there are any. Any questions by anyone?
You can also write the questions if they have.
They can also write the questions in the chat window, yes, for sure. We need to digest a lot of information to be presented before we ask questions. So currently you're training so many students. I think by when we can expect, let's say, a live translation of, let's say, you're speaking in English this webinar. When can we expect that we can listen live in Hindi or Gujarati or Marathi?
Well, Bhashani has already started doing it. Bhashani has already started doing it. Even Anuvadini does a little bit of it. So you can test these two. Check Anuvadini site and Bhashani, and they already do it for some languages. The progress is still being done. Like I'm doing Hindi to Maithili. Some people are doing some other language pairs. So things are actually happening in parallel in many places. And the startup companies which we have interviewed at the IC Match, we have identified one company from, I think, Bangalore, and they have been given a language pair, and another company for another language pair, so they'll also be doing activities simultaneously. The idea is that we need this technology in India very badly for education to happen, and therefore we actually have to be quick in that.
So currently, when this happens, let's say, I think Prime Minister Modi started also this his own speeches but then his own voice is not being used. When can that start?
Will still be a little bit more effort needed to copy, and there is a disadvantage if you copy someone's voice. The security concerns also, so people have willingly kind of stayed away from that for now.
Okay. Yeah, I think we are just eagerly waiting for this to get more and more power and more popularity. I think that's my own way. We're waiting for that. I don't think there are any questions. This was really technical, so we are still digesting all the information. I'm looking forward to your more presentations and more offering for in the Indian context. And I think you have a lot of work ahead of you with your students, I guess. Yeah. Thank you, sir. And
thank you so much. Thank you.
Thank you so much.